this is the Core Chemistry Higher Tier 2018 paper. So the first question was a nice question to get you started. Plotting a graph using the information provided. They gave you the axes on both sides. Points plotted gave you 2 marks in the correct place, and then they said draw a suitable line. It did curve up and down. If you did a dot to dot, you didn't get the mark. Describe how sulfur dioxide emissions changed between 1950 and 2010. So between 1950 and 1980, they increased. After 1980, they started to decrease. So that's where you would have got your 2 marks from. Moving on to the next question then. The government has introduced a regulation of sulfur dioxide emissions. Explain from the graph why it's difficult to decide exactly what year it came into force. Well, if you look here, 1980 and 1990, there's only a tiny increase, okay? So it only decreased by 0.5 over the 10 years. So it's really hard to tell what year because it's a really small decrease. Finally then, a balancing equation. It said that it converts to sulfur and water. So the first thing you had to do was write in the equation for water, chemical equation. You have to know it. There's no getting away from it. And then you had to balance it. Exactly. Write out what I had at the beginning and then change it with a different colour pen until you get it balanced. What I would note, which was nice and easy about this one, you could only go in the boxes. You can only write numbers in the boxes. 2, you couldn't have any more oxygens. So I would have balanced my oxygens first because there was no way of adding more oxygens because there wasn't a box in front. So look out for things like that. Question number 2 then was looking at the physical properties of group 6 elements. The first thing I did here, melting point means that something's converting from a solid to a liquid. Boiling point means that something's converted from a liquid to a gas. Describe the trend in melting points of the group 6 elements. They increased down the group. They got warmer. Their melting points was higher down the group. Give the physical state of selenium at 400. Give a reason for your choice. It is a liquid because it's melted, because it's there's melting point is below 400, so it's melted, but it hasn't yet turned into a gas. So that's why it is a liquid. Explain why it's difficult to classify selenium as either a metal or a non-metal. The reason for that is it's a semiconductor. So that means that it's got some properties of a metal, like semiconductor, quite high melting and boiling points. However, its density is quite low, making you think it's a non-metal. So it's got properties of both. Next question then was to work out the relative formula mass, or the MR. As you can see, I've done the table, being careful of the fact that I've got 2 sodiums, 3 oxygens. Completely worked it out. Then it says calculate by percentage mass of selenium in sodium selenate. So you want the total of Se divided by the total MR. Okay, and then times it by 100. That's why it's so important to draw out that table, because it helps you do the next questions. You could have left it either as 4.5 or you could have rounded it to 4d6. Question 3. Straight away when I saw question 3 and I saw the first question, I started writing down the side what they are. Are they atoms or the ions? So which particles are atoms? If they are atoms, they've got the same number of protons as they do electrons. So, and I wrote that down the side, there were 3 that had exactly the same number of protons and electrons, and I wrote that by there. You had to write all 3 or you didn't get the mark. Which particles are positive ions, which means they've got more protons, because protons are positive. Give the charges on the particles you have chosen. So F and B were positive. B was positive 1, because it's got 1 more proton than electron. F then was positive 2 because it's got 2 more protons than it does electrons. Define the word isotope. They have the same number of protons but a different number of neutrons. It's really important that you get these 3 words all in your brain: atom, ion, isotope. It's really important that them 3 words you are able to distinguish between. Number 4 then was quite a mathsy question. The first bit was quite difficult. It told you about the thickness of the Earth and saying that the crust was 0.97% of the Earth. So the first thing you had to do was work out the entire entire length of the Earth. So you had to add the three things together. I added them together without the standard form in the end just to make it a little bit easier. So it was 6.4, that worked out to 6.4 times 10 to the 6. That was the entire length. And then you had to work out what 0.9% of that would be. You could have done that on the calculator, or you could do 0.0097, times it together, keeping it in standard form. So that's your answer in standard form. If you hadn't have written in standard form, you didn't get the final mark. The Earth's crust is divided into tectonic plates, so this is explaining the theory of plate tectonics. Plates move more slowly. Plates are able to move due to convection currents in the mantle, so you had to describe how they could move. Iceland's boundary lies on a mid-Atlantic ridge between two plates, North America and the Eurasian plate. It tells you that it's a constructive plate, so as soon as I see that, I think construction. Something is being constructed. Plates move apart. Magma rises up through a gap, cools and forms new rocks. So that is how that mid-Atlantic ridge is formed, because these two plates have moved away from each other and gone through the process. Number 5 then was a rates question that was nice and easy once you actually got your head around what was going on. It told you that they were carrying out an experiment using hydrochloric acid and calcium carbonate. It then told you that you've got the same concentration of acid and the same mass of calcium carbonate were used. Using particle theory, state and explain two factors that may be responsible for the higher rate seen. You couldn't use concentration because they'd already used it. So the first one that I picked to use was to increase the temperature. Then you kind of had to explain what increasing the temperature would involve. So particles have more energy, more chance of collisions, greater frequency of successful collisions. Number 2 then, because you had to give two factors. The other one I picked was surface area, more space for particles to collide. You could have used pressure. You couldn't have used a catalyst because that isn't how a catalyst graph would look by adding a catalyst. State how the graph shows the same mass of calcium carbonate was used in both experiments, same endpoint for both graphs, same volume of gas produced. Question 6 was a question that we've practiced quite a lot. Explain the trends in group 1 and in group 7. So in group 1, reactivity increases down the group. Group 1 have 1 electron to lose in their outer shell. That electron is easier to lose when you are further away from the nucleus. Reactivity decreases down group 7. Group 7 have 7 electrons in their outer shell. Need to gain 1 more for full outer shell, closer to the nucleus, less shells, so it makes it easier to gain that final electron. Moving on then to question 7. Again, question 7 is a question that we practiced quite a lot. Discuss the method of determining which sample of water was hard, temporary hard and permanent hard. Describe methods that students could use to find out which is which. Give expected results. You do not need to include details to ensure a fair test. If they do not say that statement there, make sure you include all the details to make sure it's a fair test. So only if they say if they don't say anything about it, make sure you include the details. So number 1, add soap to all solutions and shake. Soft water will foam a lava instantly. Boil the remaining samples. Temporary hard water forms lava. Permanent hard would form no type of lava. The next question then gave you an awful lot of information about 3 water samples. The things that you are looking for are calcium, hydrogen carbonate and the magnesium slightly. And they asked you to say whether you thought Z was soft water, temporary hard water or permanent hard water. Z is temporary hard water. This is because of its calcium levels and its hydrogen carbonate levels. It has a large amount of calcium ions compared to Y, which is soft water. However, it doesn't have as many as X. That makes you think that it's temporary hard because you can boil it and get rid of some of them. The higher levels of hydrogen carbonate also are a giveaway in that temporary hard water tends to have an awful lot more hydrogen carbonate and magnesium ions. So for this one, the best thing to use was the calcium ions to work out what was going on. Moving forward then, it asked you to explain how you can make permanent hard water soft. Ion exchange is used, water is placed through the exchanger and all the magnesium and calcium, which are the 2 things that cause hard water, are replaced by sodium. Explain why resin in ion exchange stopped working after continued use. No more sodium ions left. So if you're constantly replacing the magnesium with the sodium, you're going to end up with none left. Next question then was a calculating the moles question. So it said a 1 litre bottle of mineral water contains 1.8 milligrams of dissolved calcium sulfate, and it gave you the symbol for calcium sulfate. And then it asked you to work out the number of moles. So first things first, make sure you put the equation triangle next to it. Mass goes on the top, dividing MR on the bottom, moles and MR on the bottom. The next thing then, obviously you want to find out the moles, so that's the one that you want to cover up. By covering that one up, you've got mass over MR, which is your equation that you need. Next thing you need to do then is work out the MR. Make sure you're using the MR table, because it just ensures that you're doing it completely right. And the total you get, so the total MR is 136, which I've then placed by here. Final point to mention that is really important is that you had to then convert, and they gave you the way to do it, the milligrams into grams. Mass is always measured in grams. So that's what you had to do there, conversion. If you didn't convert, you only end up with 1 mark, which is a bit unfair because this is quite a sneaky, only 2 marks as well. So 0.184 divided by 136, and that would have given you that. It said to give your answer to 3 significant figures, so there are 3 significant figures. I kept mine in standard form, which was fine. You could have not kept it in standard form, just make sure you kept it to 3 significant figures. The final question then was quite a literacy-based question. There was an awful lot of information to read. I wouldn't have suggested reading it until you knew what the questions were about, because otherwise you're going to spend an awful lot of time reading, not even sure what you're looking for. So it says, put a tick next to the statement that best describes the single definition of heavy metals is not accepted by all scientists. Had you read through it, it went on to mention that they are concerned with different properties of heavy metals. So they're not looking for the same thing in heavy metals. That sentence is just less scientific. I can understand why people ticked it, but that one is more scientific. Look for the scientific words. Properties would have been the scientific word there. Since the 1970s, the use of lead water pipes have been prohibited across Europe. Explain why this is the case. Water becomes contaminated with the toxic lead that is in the pipes, and it builds up in the body. Lead can be really, really toxic and cause quite bad illnesses. Again, a little bit more reading. Don't check what the question was. So it says, state 2 conclusions that can be drawn from the data in figure 1. Figure 1 was a graph. Okay, so the data that can be drawn from figure 1 being a graph. So the first thing, lead contamination in roadside soil at all distances is much greater in towns than in country. You can see that straight away. That's a really easy one to see. The lead contamination in roadside soils decreases between 12 and 42 from the centre of the road to the countryside. Yeah, again, that's quite easy to see. Finally, then another bit of information. It took 15 years for paint and petrol to become lead free. Next question then was quite a sneaky one, again for a 1 mark. I did do it down the bottom, so make sure you're practicing using that method. Can you see how I've just written it there to make sure I've got space? There would have been space on the other page. Finally then, an empirical formula question. It told you it was empirical formula. Remember, if they write simplest formula, it's the same thing. You had to first work out the amount of oxygen, because they gave you the total amount of lead oxide, and then they gave you the amount of lead. So lead divided by their mass numbers, which again they gave you, didn't need to look up, worked out to these, and then you had to divide by the smallest, and that's what they would have given you. It didn't double up to an exact number, so you could have just written that in there.